Hello teachers, you ready to start chapter 3, brand new module? Today in 3-1 we're going to talk about numeration systems. When you complete this chapter, you'll be able to understand and explain hopefully the following things: numbers, their origin, and their representation in numerals and models, different numeration systems including the Hindu-Arabic system, and place value and counting in base 10 and other bases. There is a lot in this section. This might be a video and a PowerPoint that you return to several times, if nothing else, to get the homework completed. Now, got a definition for you, that of numerals. Now, there really is a difference between numerals and numbers. Number is actually the idea. So when we say 5, it's the idea of 5 items. Whereas the symbol that we use for 5 in the Hindu-Arabic, you see the bottom row down here, the Hindu-Arabic system, that is just to represent the idea of 5. So really the 5 that we have at the bottom that I'm discussing right down here, and now I'm highlighting it, that's our Hindu-Arabic system. That's 5. That's a numeral that represents the idea of 5, which is a number. And look at all these different systems that we have here, and some of them we will talk about very specifically as we go through this section. But notice the Babylonian notation. Babylonian numbers were indented in clay tablets, and that's exactly why it looks like these marks. Egyptian looks like very tally-like marks. We'll talk about that in more detail. The Mayan system, look, the Mayans have a symbol for 0. Notice this first column to the left is 0. It reminds me of a UFO when I look at that value. Maybe it's some kind of seed pod, but that represents 0. And 0 is super important for place value, not to just denote nothing, but it is very important for place value. Then you've got your Greek numerals here, your Roman numerals. I bet you're familiar with Roman numerals. That is taught a lot in elementary school. My daughter is in the 4th grade now and has been working with Roman numerals for quite a while, for years. There is Hindu and Arabic, and then the combination that we currently use, Hindu-Arabic, which is a base 10 system. All of these systems are not base 10, so we will talk about this in detail, and like I said, for some of them in a lot of detail. Numeration system is a collection of properties and symbols agreed upon to represent numbers systematically. So remember, those symbols are numerals, but they represent this abstract idea of number. And again, when we say 4, we're talking about 4 items, but really that's an abstract idea. Now, originally, as you can imagine, the tally numeration system was probably used, but that can get a little bit cumbersome. But I still use this to this day, especially when I'm dealing with statistics and having to tally up a lot of information. For instance, when I'm counting test scores and I want to know how many A's, how many B's, how many C's, and I'm just flipping through the test very quickly and noting whether it's an A, B, C, D, or F, I will use this tally system. And I know you've used it before, where we use up to 4 marks, and the 5th mark we slide through. Now, why do we do that angle for 5? So it's easy to count, right? This is 5, 10, and then 3 more makes 13, instead of having to count 13 tally marks. All right, so you ready to get this started? The Egyptian numeration system. All right, so notice the Egyptian numerals on the left, very pictorial, right? The vertical staff represents 1, and then you have what we call a heel bone, which represents 10. A scroll represents 100. The interesting lotus flower represents 1,000. This is a pointing finger that is 5th down, that represents 10,000. a polywog, it's cute, represents 100,000. And then we have the astonished man, which looks like a dude with his arms up, that represents 1 million. And you certainly don't have to have these memorized, but how you work with the system is very interesting, and you may want to kind of put this idea in your head. I go into this in a little more detail here, okay? So a little bit straight from the textbook, this current 13th edition, A Problem-Solving Approach to Mathematics, says that Egyptian numeration system dating back to 3400 BCE. So you're talking 5,500 almost years ago, used tally marks for the first 9 numerals. Egyptians improved on the tally system by developing a grouping system based on powers of 10. You know, our system now, the Hindu-Arabic system, is also a base 10 system. For example, the Egyptians used a heel bone symbol, and notice that's that arc. Okay, so they're talking about it right here, heel bone, and also mentioned right here to stand for a grouping of 10 tally marks. And we have the table that I've already introduced you to on a previous page, a little larger. So what I would like to do for our very first problem is convert this Egyptian numeral to a Hindu-Arabic base 10 numeral. So notice that we have that polywog symbol, which represents 100,000. Okay. And then what do we do with these 3 scrolls? When we look it up, it says it's 100. So what do you think that means? Well, there's 3 of them. So how about we do 3 times 100? And then we're going to add that, and that heel bone symbol, there's 2 of those times 10. And then you have the vertical staff, there's 2 of those, so I'm going to put 2 times 1. So this is like an extended numeration system, or expanded is a good word to say. And then we could add all that together. Now I do have that typed up for you. I think this may help. Check this out. Did we do that? So we had, again, the polywog was 100,000. The 3 scrolls was 300. We said that right, 3 times 100. The 2 heel bones was 20, or 2 times 10, plus 2 times 1. If you add all that together, that number, or that numeral, I should say, represents the numeral in the Hindu-Arabic system that we're currently using, 100,322. It's a big number, right? So that's what that number is. So this is how the Egyptian numeration system works. Now let's check out a different system, the Babylonian numeration system. And look at the symbols here. So again, I think I told you that clay tablets were often used for numeration at this time, ancient Babylonian time. And we have this symbol here, which represents 1, and then a very similar symbol, which that would be easy to make both of those as clay marks, right? If you have a tool that could easily make that, and that's 10. But it's a little bit more to it than that. So let me explain here in detail. Again, information directly from the textbook. Babylonian numerals 1 through 59 were similar to Egyptian numerals, but the vertical staff and the heel bone were replaced by symbols shown in Table 3. Again, I just showed you that. For example, so see the Roman numeral, the Babylonian numeral that we have here highlighted. That represents 23. Now let's go back and look real quick. Does that make sense that that's 23? Well, sure, right? So the sideways almost looks like a beak is 10, and then the little tick marks here are 1. So if you have 2 of those sideways symbols and then tick marks, surely that does represent 23. Pretty simple, right? It says the Babylonian numeration system used a place value system. Now this is different than Egyptian. Egyptian, we just added all those symbols together. But the Babylonians used a place value system. Place value assigns a value to a digit depending on its placement in a numeral. To find the value of a digit placed in a numeral, we multiply the place value of the digit by its face value. Numbers greater than 59 were represented by repeated groupings of 60. Okay, what that does, y'all, is that makes this a base 60 system. So repeated groupings of 60, much as we use groupings of 10 today. So for example, check this out. So I've got the two symbols here. Now that meant 2 before, but notice how they're scooched over to the left. So this is a separate area than this. So when it's scooched over like that, you multiply it by 60. So there's 2 of those times 60 plus 20. Well, that's 20. Remember, those are 10 each, 20, but these are in the ones place, which is actually our Hindu Arabic 140. So a little bit more complicated, this Babylonian system, but it also makes it easier to represent large numbers. Again, the space indicates that those 2 tick marks represented by 2 times 60 rather than just 2. Numerals immediately to the left of a second space have a value of 60 times 60, which is 60 squared. Now, I bet you would like to see another example, and I've got one for you. This is still Babylonian. So I have 3 different Babylonian numerals here. So just in rows. So notice the first numeral is this. Okay, this is our first one we're looking at. So what does that represent? So again, notice the spacing between these. So you've got your 2, those are 10s. There's 2 of them. So I'm going to say that's 2 times 10. But since it's scooted over to the left and there's a space, that's going to be times 60. And we're going to add that. There's one of these symbols. That symbol is a 1. Okay? And it's in the ones position. Now, 2 times 10 is 20. 20 times 60 is 1200 plus 1. So how about that's 1201? Okay? And I also have that typed up for you. There you go. So again, 20 is the sideways, but it's in the 60 position. So times 60 plus there's one of these ones in the ones place. They left off that 1 in the ones place, but it's still the same result. 1201. You ready to try the next one? You want to pause it and try it on your own? No? Okay, let's do it together. All right, so maybe you did. Good job if you did. So here we go. All right, now notice the double spacing. So remember, this is ones. The second spacing is times 60. The third spacing over here is times 60 twice, which is times 60 squared. Now, what is this value? Okay, so it's the 10 symbol and the 1 symbol. So you can imagine that's 11, okay, times 60 squared, because that's the position that it's in. We're going to add that to, this is also 11, but it's in the 60 place value or area, right? And then you've got 1 tick mark here times 1. Okay? And if I'm consistent with my parentheses, I really didn't need parentheses around that first one. So I'm trying to be consistent here for you. Now again, I've got that result typed up, but I thought you might fare better seeing it real time instead of me just popping it up there for you. So again, 11 times 60 times 60, or 60 squared. This is the way that I wrote it. So if you're trying to identify what I just disappeared on you, that's the way I wrote it. 11 times 60 squared, because this is 3 over. And this is 11 times 60, because 60 is the 1 section over, and then the original section is just times 1. And so that gives us our Hindu Arabic number of 40,261. Now, really pause it. You do this on your own and come back and see if we do it the same way together. All right, here we go. Okay, so again, spacing. This is ones, 60, 60 squared, 60 to the third. Yes, indeed. So that's 1 tick mark. So it's going to be, I'm going to write this bigger, 1 times 60 to the third plus, and this is the number 11. again, because you've got both of these marked. So it's 11 times 60 squared plus this one's also 11, but it's just times 60 to the first, or 60. And this is 1 times 60 to the 0, y'all, which is really just the ones position. Get typed up. There it is for you. Big old number, 256,261 in our regular Hindu Arabic system. Now here's a good question for you. What numeral would succeed the first numeral listed? So when I mean the first numeral listed, I'm just talking about this number. Let's just take a look at this number. I could ask of any of the three, but let's just look at the first one. So succeed means come after, right? Now we know in the Hindu Arabic system, the number that comes after 1,201 would be 1,202. But it didn't ask in the Arabic system. They want to know in the Babylonian numeration system what numeral would succeed this one. Okay, so remember this was, and this is times 60. So if I'm going to add 1 to this, I'm looking at the ones place. So how about, so that's 20 times 60, but then to get 1,202, this would need to be a 2 instead of a 1, so I'm going to have that symbol twice. Okay, if I want to make it really fancy, I would color those in, just like they're colored in here. Correct? Now, a far more difficult question, and I'm asking this probably very prematurely, but I want to address it anyway. What about to precede the first numeral? So succeed is what I have here. What about precede, which means comes before? Now, the numeral that comes before 1,201 in Hindu Arabic is 1,200. Of course it is, right? But how do I write that in the Babylonian numeration system? All right, well, how about we just get rid of that tick mark, right? So that would give me this. But doesn't that just look like 20? How do I know that's scooted over to the left? And see, this was an issue with the Babylonians. It turns out they had to add something extra later, and I may not even draw this symbol correctly. I found when I did the homework I didn't need it, but they ended up building something called a placeholder, which is, again, kind of a reason that we have 0 now. If they had nothing in a certain place, which is the ones place in this situation, then what they would do is they would put this double triangle placeholder. Again, I could have this upside down, forgive me, but that would give us simply nothing in the ones position. I scoot over, this is the 60 position, so I have 20 times 60, which is equal to 1,200. Interesting, right? And a little bit complex. As you can imagine, being an accountant in Babylonian times could be a little bit of a difficult job, but once you got used to it, it wouldn't be any more difficult than what we do right now, although I really appreciate base 10 quite a bit. When you spend time with these other numeration systems, it's like, whoo, base 10 is so much easier. Now let's get ready for a different numeration system. How about the Mayan numeration system? What can we do with this? Again, I'm going to refer to the textbook for details for you, because I know you're wondering some of these things. So in the early development of numeration systems, people frequently use parts of their bodies to count, as you can imagine, right? Probably why we have a base 10 system now. Fingers could be matched to objects to stand for 1, 2, 3, 4, or 5. 2 hands could then stand for a set of 10 objects. In warmer climates where people went barefoot, people may have used their toes as well as their fingers for counting. The Mayans introduced an attribute that was not present in the Egyptian or the early Babylonian systems, namely a symbol for 0. Remember, we ran into the issue just a minute ago that the Babylonians, because we tried to precede a number And we needed a 0, but they had added that later. Well, the Mayans had a 0, and it's a placeholder. It's not just to represent nothing, but 0 is a placeholder. You need that when you have nothing of a certain value, okay? And you're already getting a feel for that, I know. The Mayan system used only 3 symbols and based their system primarily on groupings of 20 vertically. I'm going to highlight that because that's really important when we start trying to write the Hindu-Arabic number for some of these Mayan numerals, okay? So representations for 0 through 10 in the Mayan system are shown in Table 1. Again, the 0 looks like a UFO. Again, it's probably some kind of pod. I haven't exactly researched what that symbol comes from, but maybe some kind of seed pod would be my best guess. Notice the groupings of 5, where each horizontal bar represents a group of 5. Okay, so you have a dot for 1, a bar for 5, and again, a spaceship for 0. Please don't repeat that to other people, but I bet your students would call that a spaceship too. So thus, the representation for 19, look at that. So notice we have 3 bars. Now remember, the bar is 15, so I'm highlighting what I'm looking at here. The bar is 5, I'm sorry. The 3 bars would make it 15, and then 4 dots. So that makes sense that that's 19, right? It says the representation for 20 was the 0 symbol, and then a dot above it, and you're thinking, what in the world? So this is this vertical representation. Now, I do have a little bit of an issue with some of the textbook, and I'm going to point this out to you in another problem in a minute. But when they do their vertical representation in some problems, see, this dot to me looks very close to our 0 symbol. I think it should look more like this. Now, you're thinking, what in the world is the difference, Miss Wilson? This looks stacked right on top of it. But when they talk about multiplying by 20, which remember the Babylonian, we multiplied by 60 because it's spaced over. Well, in the Mayan system, it spaces upward. So anything down here, lower, is times 1, okay? And then when you jump up a notch, it's times 20. And so this is like 20 plus 0 ones, okay? And it even says that down here. But again, spacing I think is very important. And I know why the spacing is probably not there because they're trying to get that within text. But I want you to keep that in mind. I think it really should look more like what I have here. But I am no Mayan numeration system expert at all. I'm sharing some information that I'm not super fluent in either, but I think it's awesome. I think it's very interesting. All right, you ready to do a problem? Okay, so notice the spacing again, like I talked about on the previous slide. So here, my thought is we're multiplying times 1. This is like the ones position, but we spaced up, and this is like the 20s position. So let's see if we can pull this off. So again, the bars, remember the bars are 5 each. So you've got 5 and 5 is 10, plus a dot is 11. So you have 11 times the ones position. Well, above it in the 20s position, I'm going to go ahead and put times 20 because that's separated, that space. And again, these are vertical, whereas in the Babylonian, we did this spacing horizontally like we do our system. All right, so we've got, again, 2 bars. So those bars are 5 each, so that's 10. And then 3 dots, so how about 13 times 20? And we would calculate each of those values and then add down to get our result. Now I have this typed up as well. So let's see if we did the same thing typed up. And look, we've got 2 times 5, that's our 10, plus the 3 dots, so that's our 13 times the 20. That's what we had, correct? And then for the second row, we had 2 times 5 plus 1 times 1. So again, 2 5s plus 1 1 times the ones position. And that gave us 11 times 1, which is 271. Now, what we had written down, I know you noticed this, is actually this information right here. I did this audibly, but I didn't write this down. But that would be our Hindu Arabic 271 number, so numeral. So this is equivalent to this. Interesting. Don't you feel like you need to do that again? I feel like I need to do it again. So here's one for you. Bottom left over here. So notice I got a spaceship going on again. Remember what the spaceship represents? It's 0, right? While you're pausing it, I'm going to look it up and see if I can figure out what that symbol comes from, what the idea is. All right, you ready? Okay, I looked it up. You know what that is? Maybe you guessed it. Maybe you already knew. That's a shell. Okay, so my seed pod, it's not right. It's a shell. And that makes perfectly good sense to me now. So here we go. Remember, this works vertically. So the lower symbol is going to be times 1. And then the upper symbol is going to be times 20. Okay, so if we look at the upper one first, I've got 1, 2, 3 of those bars, and each of those is 5. So it's 5, 10, 15, plus the one on top, which is 16, times 20. We're going to add that to the lower one. Well, remember, the shell represents 0 times 1, so we're going to add 0 to that. And then when I multiply 16 times 20 plus 0, and I also have it typed up for you, that's going to give me my answer. But right now, you probably see the fade that's going on here. That's my PowerPoint and want to not respond. So, yeah, there we go. There it is. So 3 times 5 plus 1, that's our 16 times 20. We add that to our 0 times 1, and that gives us the Hindu Arabic equivalent of 320. Now this question should look familiar to you. What numeral would precede this numeral or succeed this numeral? Okay. Which one do you want to look at? Why don't we look at the upper one? I could have asked that question about either one, but let's go with the upper one that I've got highlighted green at the top. So precede, remember, comes before. Now, we know what precedes here. That's going to be 270. Okay? So that means that this is 271. What makes the extra 1? Well, again, these bars here gave me 10, plus the one more gave me 11. So what if I got rid of that dot? So we would keep the one that's times 20 at the top, and then below the times 1, I'm just going to get rid of that dot. And you could check it. This would be 13 times 20, because we've got 13 here, and it's in the separated 20 area. And then here we have, that's just 10 times 1, and that should add to 270. Okay, so this would answer the precede question. How about succeed? Let's come after. All right, so after. That means we need 272. Again, above is 271. What gave us the 1 part is the 1 dot here. So what if we kept, again, the 20s place the same, but the 1's place, we need an extra dot, and this would be the picture for succeed. Are you feeling it? I hope so. Now, there is just a touch of strangeness with the Mayan numeration system. I did not see that this shows up in the homework, but it is something that I wanted to point out to you because I don't feel like I'm doing you justice if I don't mention this strange situation. It says for a number written using 3 rows in a true base 20 system, the place value of the symbols in the top row should represent one group of 20 squared. So let's come down here, okay? I want to point something out. Remember, the 2 problems that we did had just 2 sections. So this has got 1, 2, 3 sections. And again, to point out what I mean, this is the ones. This would be the 20. Now in theory, this would be 20 squared. Remember, we did this with the Babylonian system, except we use ones, 60, 60 squared, 60 to the third. This is a very similar thing, but vertically, okay? But, and this is where the big but comes in. It says, however, the Mayans used 20 times 18 instead of 20 times 20. So 20 times 18 is 360 instead of 400, which is just odd. I don't know the motivation behind that. I'd really want to research it, but we're going to move on in this video. We're going to keep going. It says, thus, instead of place value of 1, 20, 20 squared, 20 to the third, 20 to the fourth, like the Babylonians did with 60, they used 1, 20, 20 times 18, which is 360, 20 squared times 18, then 20 to the third times 18. So if you come down here and you look at these lines, this is the ones place. This is exactly what we think it should be. That's a bar, which is 5, and then the 4 ones, which is 9 times 1, right here, okay, which of course is 9. But then the one above it is just like we did before too. It's 2 bars, which is 10, plus 2 more, which is 12, and that's in the 20 area, and 12 times 20 is 240. But it's this third area, okay? So it's 1 bar, which is 5, plus 1 more, which is 6. But instead of times 20 squared, which is 400, we're going to multiply 20 times 18. And that gives us 2,160. And you add down to get 2,409. And I say it didn't show up in the homework. It didn't show up in my homework problems. But you could have an iteration of a problem that it does. And so I want you to be comfortable. Not only that, you might find this highly important. And you may end up teaching something similar to this to your classes. So I want you to have accurate information. Okay. Now you could try this next one on your own. The answer is there for you. I'm not going to do it in the video. I'm also running over my 30-minute time, but I also want to get all of the numeration systems out, and I want to talk about the Roman system before we shut this video down. So this one's going to be a little bit on the long side. And it's quite possible that the Roman numeration system might be the easiest for you just because you're familiar with it. But if not, it can be a little bit challenging. There's a lot of memorization that goes along with it. Let's read just a little bit straight out of the textbook. The Roman numeration system was used in Europe in its early form from the 3rd century BCE. Imagine when that was, 3rd century BCE. So we're talking 200 to the year 299, is still seen today on quarterstones, on the opening pages of books, and on the faces of some non-digital clocks. The Roman system uses only the symbols shown in Table 5. That's all of the Roman numerals. Roman numerals can be written using an additive property. That does make it easier than some of this base 20, base 60 stuff. For example, but look at that, okay? So I'm going to highlight what I'm talking about here. Things are moving around because my pen didn't work. Let's see if it'll work now. There it goes. Okay. So the M represents 1,000. There it is. So that's where this 1,000 comes from. Look at the next letter. A D represents 500. So 500. And then a C, this is a neat number because they just went down the line, right, is 100. And then next is an L, which was 50. And then next is the X, which was 10. And next is the V, which was 5. And then finally the 1. And so they used one of each, which is actually 1,666. All right. It's not quite that simple, as you know. They use a subtraction property, but let me not get ahead of myself. So, well, actually, that is what they mention next. To avoid repeating a symbol more than 3 times, as in 1, 2, 3, 4, that could be 4, a subtractive property was introduced in the Middle Ages. For example, if 1 is the immediately left of V, it is subtracted from the V so that you have a 1 and a V to represent 4 instead of 1, 1, 1, 1. XC represents 100 and so on. Okay, it says in general, this is important, in general, if I could get this to highlight, in general, only one lesser number symbol can be left of a greater number symbol, and the pair must be one of those listed in Table 6. So let me show you what we got going on here. Again, my PowerPoint is wanting to misbehave. So let's take a look at the Roman numerals. Again, you recognize those, you've seen those in a list. But then, when we use the subtraction property, so again, 4, the V is 5. So if you want to note 4, instead of doing 1, 1, 1, 1, it's less symbols to use 1 and then V to represent 4. Just like 9 would be 1x, which means 10 minus 1. Again, if it comes before a higher valued numeral, then you know to subtract. So XL, L is 50, X is 10, 50 minus 10 is 40, CX, C is 100, X is 10, 100 minus 10 is 90. You see how that works. D is 500. I have a hard time remembering that D is 500. C is 100. 500 minus 100 is 400. And CM, M is 1,000. C is 100. That would give us 900. So that subtraction property can sometimes make things confusing, but it is using less symbols. Now, one more thing I had to add to this, and I'm going to be honest, this is not something that I was aware of because my use of Roman numerals is very limited. I just do the basic, like I look at the end of a movie and calculate what year it was because they won't give it to me in Hindu Arabic. It said also in the Middle Ages, a bar was placed over a Roman numeral to multiply it by 1,000. Okay, so if you ever see a bar over a Roman numeral, you take that value and multiply by 1,000. The use of bars is based on a multiplicative property. For example, 5 with the bar over it is 5 times 1,000, which is 5,000. CDX, notice if the bar goes all the way across. Now, don't look over here and cheat, okay? Don't pay attention to what I've got highlighted. CDX, what would that be? Remember, C is 100, D is 500, so that's actually 410, right? But then you can put a bar over the whole thing. That's 410 times 1,000, 410,000. So to indicate even greater numbers, more bars appear. For example, V with the 2 bars above it, that's V times 1,000 times another 1,000. So anytime you see a bar, that's times 1,000 for every single bar. CXI, again, don't cheat over there and look. Remember, C is 100. X is 10, since it's to the right, that's 110. I, that's 111. And then it looks like 2 bars to me. So that's 100, or 3 bars. I'm struggling to see 3 bars, but they're telling me it's 3 bars. So 111 times 1,000 to the third would be a very large number. Okay? Now, several properties might be combined to represent some numbers, for example. And what do they mean by the properties? Remember, there's the additive property where we just add the Roman numerals together. There's the subtraction property where if you have a smaller Roman numeral before a larger one, you subtract the larger minus the smaller to represent, for instance, 4. And now we have this multiplicative property where we multiply by 1,000 every time we see a bar. Okay, how could we use that on what we've got going on here? So let's take a look. Notice the D has the single bar over it. So we know we're going to multiply whatever D is. Recall that's 500 times 1,000. Now we're going to add a C to that, which is 100. L is 50, so that's 150. And then you have a 1 before an X. And again, whenever the order is reversed, if you don't start largest to smallest, when you have that 1 before the X, that's going to be a subtraction property and you get 9. So I have this typed up. We've talked about it, so audibly we've done it, but here we go. Again, the 500D times 1,000 because of the bar, plus the 100 because of the C, plus the 50 because of the L, plus the subtraction property 10 minus 1, which gives us 500,159 in Hindu Arabic. Now, what properties? We mentioned that too. Multiplicative, additive, subtractive, and then the whole thing is added at the end. So there's a lot going on with Roman numerals. Here's something else I want you to understand, is that these are not unique. There's more than one way to depict a number. I bet you could probably think of how you could do one. Still following the rules too. I don't mean like if you break the rules and not use the largest value you could use first. You still can write numbers that are not unique, especially because we're using that bar. As you can imagine, there's more than one way to depict 1,000. Think about that. All right. One more thing, and I'm going to shut this long video down. We'll come back for part 2 later. What numeral would precede this numeral that we have here? And by this numeral, I mean the one we just worked on. Oh, my pens. Whenever I move the whole screen around like that, I do apologize. It's probably really hard to look at, but I don't mean to do it, as my pens won't accept. So we decided that this was 500,159. Now we know the number that precedes that would be 500,158, but that's in Hindu Arabic. We want to write that in Roman numerals. So how do I depict 8? I'm going to get rid of the 9, which is the 1x. That would be D with the bar, CL, and instead of the 1x to be 9, I'm going to do V1, 2, 3, and that's 8. So that would be the value that precedes that number. Now in red, let's do the value that succeeds that number. So what really succeeds it in Hindu Arabic? 500,160, right? I started to write 50 again. 500,160. How am I going to write that? How do I write 60? Okay, the 500,000 is the D with the bar. That's 500,000. The C is the 100. Now again, how do I write 60 in Roman numerals? I need an X and the I, right? So that is going to be, no I don't. Shh, don't tell anybody. Okay, 60 is 50 plus 10, right? What's 50? It's an L. Okay, plus 10 is an X. Try that. So 500,000 is the D bar, the 100 is the C, and then 60 is 50 plus 10 more. That's the value that succeeds it. Okay, so 43 minutes later, we finished numeration in terms of other systems. For part 2 of the video, I want to spend some time with our Hindu Arabic system and then talk about base 10 blocks. I also want to talk about numbers that are base 2, base 3, base 5, base 12. Very interesting, very close to what we just did with our numeration systems. Have a great day. If I don't talk to you again until tomorrow, might need to be tomorrow, we'll see you for part 2. So have a good one.